How are you? So I'm going to talk a little bit about CartoDB and how it can help you do better mapping work and analysis. But I guess I always is this microphone? Oh, it is good. Can you hear me? Okay, great. So I always like to ask who's used CartoDB before. Okay, good. So at the core, I'm going to explain what CartoDB is really fast and give like the slide pitches or pitch slides that I normally do, and then we're going to go into something a lot more fun. So CartoDB is at the base, it's a database. It's a geodatabase that takes data and pulls location out of it. So you can really simply use it in all of your projects and in development projects and in all kinds of different formats. So basically, it's a database that on top of it has a really simple editor. It has some location services built into it, and then ways to pull data out through APIs, and then you can build your app on top of that. And the four things that we do that are different than other companies that you might see is that we're in the cloud. We don't really do anything on the desktop except for some on premises behind certain firewalls. So we're really easy to use. I've edited maps on the subway between stops in New York City before, which really on my phone. And we have analysis tools embedded. Right now it's in our SQL interface. And in the future, it's going to be in a new interface that we're coming out with in the next couple of months. And we give you, it's a really great self-service product, so you can just pull your data in and start getting busy right away. And then the thing that I like about it the most is that it's really shareable, and you can make a map and send it to your mom really fast. And we've got some great examples of things that people have done with CartoDB. Please hold up internet connection. Let's do this. It's not. It's going to give me this is the first time it's going to make me go to the thing again, isn't it? Hold on. 192. Do you know this trick? When you go to a place and the window has to pop up, you just put in 192.168.1.1, and it goes to the authentication. Yeah, I know. I learned that. It's basically the router IP address, and it's 192.168.1.1, and it works everywhere. So if that window doesn't pop up, then that's it. Okay, great. So you can see we have a great gallery on our site that shows all of the wonderful things that people have done with CartoDB. Wall Street Journal, cities are doing great things. New York City is a big client of ours. So take a look. I'm going to show you a couple of things that we have that we're really proud of. So let's move on. So we have a lot of data coming out in the world, and one of the goals of CartoDB is to make it so that you can take that data and make it into something a little bit better that suits your needs. And that's been done for a long time in a lot of different ways. So, but it really is. It's coming to a point where we're starting to understand how to make data a little bit better, and it's actually starting to have a difference. And I hate following that talk that was just given in the main room, because he was great. This is how it used to be done. People would actually make the data, and they would have a really great interface with it. With like one-on-one, and with maps were made with drawing boards and rooms full of people each taking a different segment of the map. But now it's done like this. So we have open data. This is the global open data index. You can look at cities and see how they are using data and how they're offering data up to the people of their cities or beyond, and how they can actually make a difference by finding hidden patterns or looking at it in whatever lens they want to look at. So we have data. We now have data. We want to process it. We want to make things out of it. And data is the thing that kind of is between us, and makes us all understand each other a little bit better. So there's a lot that's happening. So just getting the data out there is just one part of the whole conversation. And the second part of the conversation is accessibility to the tools that can help you better understand it. Those calculating tools that the guys in the 30s, these were expensive. These were really expensive, and they were not accessible to everybody. So you were limited in what you could do. And now we have open source tools. CartoDB we have a free account that you can just jump in and start doing things. I'll give you a link to a boosted one in a few minutes. But beyond us, there are a lot more free tools out there. QGIS is making a big difference in people being able to jump in and do some really deep analysis. And you can basically, if you figure out what you want to do, there's probably a tool that somebody has made, and then you could always just learn Python and just do anything you want. So data is a product of where we've been and what we need. It's conversations in the 20th century were a lot easier than they are now. I'm sorry, I'll skip past them. We had, but the thing is, not everybody had access, so we had some really big problems that we didn't really realize were going on, or maybe we did, and we just kind of didn't have enough data to get behind them. Cars is a great example. We're realizing now that cities are deeply are changed by cars in ways that maybe are not the best for everybody. DDT. We had data on DDT, but we didn't really, we would watch this happen, and not really think anything of it. It was just kind of another thing. But in this world, when we see moments like this, we have data behind them. The Orlando shootings yesterday. There's a lot of data coming out so quickly about that event, and it's kind of amazing how quickly things are changing. So accessible data is the key to our security and our well-being. And the challenges are becoming more complex. We have a lot more people to deal with around the world, and getting into some of the answers is a little bit harder. So we need the data, we need the tools, and we need to have this discourse go into a much more informed level. So 5 lessons that I've learned from CartoDB. First of all, if you want to get that account, here it is right here. It's bit.ly dynamic-CartoDB. It's got one extra feature on it, which is sync tables, which means you can take data and you can sync it from another location. So please, I'll have this at the end again too, but I'm going to show you a bunch of work and you're going to get excited and you're going to want one of these, so write this down. So CartoDB has taught me that open source technology is the future of data. It's not big contained software that only a few people have access to. It's open software that everybody has access to. And it's done with strong community. It inspires innovation by getting into the cracks. And it's really easy to get into projects and integrate and to mix together. Open technology that we collaborate on that's outside of CartoDB is GDAL, Postgres, which we're built on, and then MapNIC, which is a great product on rendering. And then open technology that we create is CartoDB itself. We're an open source product. We do have we have a business that we've made out of it, a business model behind it, but anybody can just go download our entire product and put it onto and build it out themselves and maintain it themselves, and fork it and develop it if they want to. So CartoDB Postgres, our data services, we have a lot of services that come from companies like Mapbox that give us routing and geocoding, and we use OpenStreetMap quite liberally. Windshaft, which helps us get analyses into our product that you'll see in a few minutes. JavaScript libraries, animation libraries, OSM base maps, and finally our rendering, our Turbo CSS and engine that visualizes our data really well. This post was by Tom McWright of Mapbox a little while back. CartoCSS is the core of our visual styling. It's the language. It stems from CSS, and it was built to make the maps look really beautiful. So basically, it's a CSS that's styled just for maps themselves. And Mapbox shifted away from it and went into their own really great language. But he declared that CartoCSS was over. And did it in a very clear way, but something that we don't agree with. And we have taken over CartoCSS, and we're developing it even further, and we're opening that up too. So one of the things that comes from that is you don't just dead end a really great language that people are really used to using and people have trained themselves on. So we feel really strongly that it's a great language and it's helpful, and I use it every day, and so we've decided to add on to it and make it our own and keep the community involved and keep them interested in what we're doing and look at what they're doing and have them contribute. Every day we have issues come from onto our GitHub that we add into our workflows, and we make our product better because of the people that are out there saying, this could be just a little bit better, and this is how you'll do it. And then they tell us, and they give us a GitHub issue, and they give us a push request or a pull request, and we frequently bring that into our product. So the second part of it is that data services, analysis, and design are completely inseparable, and I believe that from the core of my being. I am actually a cartographer by trade. I went to CCA in California and learned information design and cartography way before any of this was going on. And I was making maps by hand at first, and know how hard that is, tracing aerials from in Illustrator after a while, and then finally, and I managed to avoid GIS until about the mid '90s when I worked for regional plan. I'm sorry, the mid 2000s when I worked for a regional plan association, which is the 31 county regional planning group in New York City, and it's getting so much easier. So, but I'm sorry, back to what I was saying. These three things are completely inseparable. Design is one of the key things that gets you where you're going and makes information clear. And the services that are coming about with the geocoding and routing and making data more understandable are really, really helpful. This is actually geocoding that we are doing in our product now. It's using MapZen's Valhalla engine. And it uses OSM to help route, and that is built into our product now. This is our torque engine, which takes data and allows you to make it active, so you can put it on a timeline and you can see what you can actually look at it in motion. And finally, we have some distance matrix and isolines that can automatically create. I'll show you. This is a walk map for how long it would take you to walk in each of those concentric circles. So those are the data services that really help make things a lot clearer, and those have been really hard to do over time. When they did, there was actually a map at RPA from the 30s. It was a distance matrix. It was an isoline, and it took them apparently 6 months to do this, something that would take us 5 minutes to do now in our isoline product. So analysis must be robust, beautiful, and impactful. And I actually borrowed these slides from a coworker, and I don't think the word impactful even exists. So so we're just going to let that go. But he has some great slides, and I like to steal his work. But anyway, it's spot on here. Analysis needs to have some weight to it, and has to be communicated beautifully so that people pay attention to it. This is an example of that. We saw what was going on with inside Airbnb. Murray Cox in New York City has been scraping Airbnb's site for a long time and has pulled all that data together and has it available freely for anybody that wants it. And he came into the office and he was talking to us, and we took his data and we started analyzing it and looked at every big city in the U.S. to figure out what was going on with Airbnb, and we made it a deep analysis, and we looked at it really closely. We were fair and objective about it, and then we kind of released it to everybody who wanted to see it, and we found out that which this does not diminish the problem of Airbnb, or if there is one, that the impact of Airbnb on certain neighborhoods in New York City was not as much as we thought it was, and it was not taking a lot of space away from people because the rentals that were being done were so infrequent. But it takes a lot of thought and a lot of really careful planning and a good eye for design and how people can actually understand analysis just a little bit better. We woke up on the morning of January 13th to word that the L train in New York City, does everybody ridden the L, is shutting down for 2 years, which is going to basically cut Brooklyn off, or North Brooklyn off from Manhattan, not all of North Brooklyn, but and so we did a great analysis, and this map was actually an error map, but that's the L line that runs through. And that is the routing using Valhalla again to get everybody into the route everybody would take to get to the L train. And we figured out that 144,000 people a day would be affected by this, and that it's going to have some pretty severe consequences. They've just announced that it's going to be happening in 2019 for 2 years, and they're going to completely shut it down, and we don't have any idea what we're going to do. So because we just moved our office right out here. And I moved right near it. So we'll have to move or something. I don't know. And then this was actually the second part of that analysis, was looking at the demographic analysis, because when the L train first hits Brooklyn, it goes into what's well known as a hipster neighborhood, Williamsburg, which I'm sure you've all heard of. And then, so you can see on here Greenpoint and South Williamsburg and Bushwick. But in reality, the L train serves some of the highest poverty, actually the highest poverty neighborhoods in New York City, and gets people to work and keeps them foraging, from what we just heard in the last talk. So it's a really scary shutdown for 2 years and could actually cause some really big problems. And so we took some clustering analysis that we were developing and is now making it into our product, and took a good hard look at the L. So then the fourth thing is data standards must strive for optimum usefulness, accessibility, and ease of analysis. And we're still getting there, but what we've embarked on a new project called the Data Observatory, which I'll show you in a few minutes, to get data into our products so that you don't have to actually get it yourself, using some of the most common data sets, national data sets. And we're starting to have a larger conversation about data standards and working with other companies and other organizations and institutions to help better understand what that means. So this is actually the Data Observatory. We've started with the ACS and the census, and we have the whole ACS and census for 2010 to 2014 in CartoDB, and it's something as simple as this for the boundaries specifically. We have boundaries and measures. This is how you get Brooklyn in just through a SQL statement, and then you'll see New York State come in as well. So we've basically we're storing the data for you, and then we're giving you access to it to pull in very quickly. This is starting in our SQL interface, but then it's going to be in our editor, so you'll be able to just drag and drop. Give me all the boundaries within this certain radius, and you can just pull it right in, saving you the time of going somewhere, getting the data using FactFinder or any of the other platforms, and having to do that extra work. We're just keeping it there for you. And we also did a great deal of shoreline clipping, and made them really nice and tight in ways that we had always wanted to see. So the last thing is that data is not just for the data scientist. Data is for everybody, and that means from the hobbyist to the admin assistant who wants to make a quick map to get a promotion, to the CEO, to anybody who wants to do it. It should not just be for the data scientist. We feel like GIS professionals are fantastic at their jobs, but they should be allowed to do the deeper analysis and let maps be made by everybody. And that's what CartoDB is for everybody. And our challenge is to make it easy to use. So the biggest thing that I'm going to go back into Data Observatory for a minute. So finding data is not easy. And I'm going to go to the site. So these are some of the data sets that we have pulled together. So this is the census and ACS, and this is being rendered live in CartoDB right now. This is our reference site that we use internally to look at the data. So this right now is households in the US. So if I zoom out, this is on the fly pulling from our database. It's rendering it as we go. It doesn't actually have it. It's not stored anywhere. So I'll actually give it a second. Come on. If it takes too long, I'll switch. It's a huge data set. There we go. So this is every census block group in the country, which is a really large data set. And we've got them all here. And then, so we've got the US, so I can switch this to, let's go to the Gini index. I think the Gini index looks interesting. It's not available for that, so I need to do it by county. And then no denominator. And so we're actually I'll talk about it in a second, but we're also normalizing data. We're giving you the ability to normalize data, because that's one of the biggest problems is people get this data and it's just flat data and it doesn't mean as much as it should because it's not normalized against something else. And then let's go to 200,000. So this is wealth. So 200K. There we go. Income of 200,000 or more, and by households. So now we can explore a lot and start looking at we can start getting into our data a lot faster and start making it into something else. And just today we released the UK. So if we go here, in this tool, you see that the UK will pop up. Let's see, total population. He might be fixing this. He told me that things were going to break while I was actually up here. So so anyway, so this is our catalog of what we do. So that's a little bit of an example of what we're working on. And we're also looking for the next national mapping agencies to bring in. We're working on France and Canada, and we have about 5 or 6 others that we're kind of eyeing. So how does that happen? What does it look like to actually make this? This is where these are some animated GIFs basically of searching for that data. So basically it's an observatory search looking for inequality data. So that he finds the Gini index. He is Stuart, who's actually making this video. He gets the number, then he goes into the next thing, which is getting the boundaries. Gets the boundaries of the census tracts in Baltimore by point and radius, finds a point, gives a little bit of a buffer, and then uses some of the census codes to kind of target. Applies the query, and they're there. So then next would be adding a measure. I think he's going to use the Gini index. I forget if he does or not. Observatory search inequality. Oh, he did the same. I put the same video here. Oh, this stuff. Try this one. Yeah, here we go. So this is the Gini index one. So he builds a new column for it, goes to SQL, and adds the measure by ID. That's the Gini index. Applies the query, and it populates it. Right, checks it. It goes back to the map view, and it's there. Makes a choropleth out of it, and then it's done. So that's how simple it is, and that right now is a bunch of SQL queries, which is a little bit hard for a lot of people. But in the next couple of months, you're going to start seeing it pop up in our interface, and you'll be able to actually just do a drag and drop. So the next thing, looking at aggregation and normalization, is really, really frustrating for people because it's as a concept, I think people understand it really well, but doing it sometimes isn't that clear. So Stuart made another video here. We're going to go through that. So he did this with tweets. He went and got Twitter from about Chick-fil-A. Chick-fil-A is a fast food restaurant that's mostly in the South. And he got tweets about Chick-fil-A because he wanted to figure out where exactly people were tweeting about it. And tweets are well known for being sort of flimsy data statistically. Like they're basically 0.05% of tweets are geocoded, and from those geocoded tweets, there isn't a whole lot that you can actually get from them except a little bit of sentiment. So he's deciding to aggregate them by county here, and then you can start getting a little bit more. You can start looking at some patterns. And so he just aggregated them by county, and now he is normalized by the population. So then it's tweets by county, by the amount of people in that county. And he did this all in SQL without importing any data from a file or messing with any sort of file outside. All right there. There we are. Okay, I'm going to move on because I'm kind of running out of time, and I want to show you a couple of great things. Last week we had. This is an example of normalizing and how you can actually augment your data. So this was the Parks Department does a tree census every 10 years, 95, 2005, and 2015. And this is their tracking site that they did in CartoDB. So the Parks Department uses this to track how the trees are being counted. And you can see this by New York City borough. So 68% of Queens trees are counted, 82% of Brooklyn, 100%. But if we zoom in here, this is a great example of our zoom level styling in CartoCSS. You can see that the unit changes, and then it goes down to I think it's census tracts or neighborhoods. It's by neighborhood. So then you can see by individual neighborhood, and then if you keep going in, you can get to the block face. So then you'll start seeing the trees on individual block faces, so, which is great because this allows you to do like 3 things with one map. And you can show an overall view, a mid view, and then a close view. And that's the magic of Carto CSS, and you're noticing how quick this is and how easy it is to do. This actually would not be that much coding to do this. So basically, on the top level, you're having only the boroughs show. On the second level, you're only having the neighborhood show, and then on the bottom level, you're only having the block faces show. And you're editing, you're pushing those out through a simple little bit of code. I teach people CartoDB in an hour when I teach at Columbia, and I have them learn it in an hour, and then we spend the rest of the class or the rest of the semester just making things, which is really wonderful. And then from that tree census, we came back and we have a new dashboard feature because it's really hard to code in JavaScript. We've made it so that you can actually just make this dashboard in the interface now. So these are all the trees they counted in 2015, and we tied them with Data Observatory to the census. So every tree has all of the information that it needs from its census block. So these census trees are massively informed, and so they've got how much vacant housing, how much unemployment, and how much population, and the percent income that their neighbors have spent on rent, and how many people own their homes. So the goal of this was to look at the tree diameter, which is a sign of health that the Parks Department uses for trees, and then to segment that by or is it percent income spent on rent? No, that wasn't actually it. Let's just do that one. So you can look at you can start looking at how I want to normalize this right here. You can start looking at how different neighborhoods that have different wealth, how well the trees are cared for there. And at that point, and when the Parks Commissioner saw this, he was thrilled to see this because then he can start taking action and figuring out why that's happening. If it's his process that's causing that, or if it's just the trees, or if there's an environmental factor, you can start seeing that. So there the trees are 9.71. Let's go. I'm probably not going to get a result that's I'm looking for, but let's go. So 9.71, 9.24. The trees are a little bit smaller where people will spend more on rent, but that's anyway. I think you probably understand the point. But then this is also another example of the zoom level styling that's pretty amazing. You can kind of zoom in here, and you can understand the qualities of the trees and what kinds of trees are in certain areas. And so we have a list of all the trees that are available, and you can actually zoom in on each one, and you can look in the categories and just explore a lot more. So this is one of those tools that we're making it really easy for people to get from question to an answer very, very quickly. And here's another one. This is the Department of Buildings. Where did my mouse go? So actually, I'm going to skip past that one. I have just a little bit of time left. This is one of my favorite maps. Oh. Oh, great. Good. I have some nice examples to show. I want to go back to this, though. Did I not put the link in this one? Hold on a second. I want to find this map for you because I love it. Reportel. There we go. So this map is the NYC Daddy map. One of a reporter that used to work for the Wall Street Journal and now works for WBEZ Chicago took New York City taxi data, which is open, and took the origins and destination data, geocoded that, and looked at just the area right around the New York Eagle, which is a leather bar, for a gay leather bar, and wanted to find out where everybody was going. And what he was after a little bit was gay neighborhoods are going all over the place. People have no idea where they're living and what's happening to gay neighborhoods because they're all just breaking down. So he wanted in this exploration to find out where people were going when they left this bar. That's a very popular hotspot between 12 a.m. and 5 a.m. and kind of track where they were going to see if he could figure out where some of the new neighborhoods were. And so he took all the little blue dots are the destinations when someone left here and went there. And so he started doing a little bit of analysis on on what that meant. So obviously we have Hell's Kitchen up here is pretty dense. Chelsea seems to people are taking taxis for really a ridiculously short time periods, and they should just be walking for God's sake. Yeah, but it's right. And I mean, it's such a safe area too. I don't know understand. Yeah. So you can see Chelsea kind of emerging here a little bit. Surprisingly, West Village is very, very light, which has been the traditional gay neighborhood. East Village is also very light, maybe here a little bit, but that's actually where the other bars are that close at 6 or 4. So you can't really tell if people are just kind of going to other bars. But then when we start going out in the other outer boroughs, you can start seeing some patterns like out here in Long Island City. Like this is one building or something. So this work has been carried on, and I have a student at Columbia that did this on a much larger scale. I actually made a map called Outgoing NYC. This is all part of a process of finding hidden communities, and using taxi data can sometimes help if it's relevant. So I did a map where I looked at the history of the 150-year history of gay bars in New York City, went back and dug through New York Public Library and rummaged through all the stacks and scanned everything in, and then started adding the data into a Google spreadsheet, synced that into CartoDB, and then made an application on top of it with a little bit of JavaScript and a lot of help from my friends. And one of my students ended up using this data set to source out where the actual neighborhoods are shifting, and did a really wonderful project. I don't have those slides with me, so I can't show you. A bit nice big tease, but it's really interesting to watch, and a lot of that depends on he took the origin and destinations from the bars that I had in my database and found out where people were going. And so an open data set like the taxi data set in New York City is really doing wonderful things to help us better understand some of these hidden communities or communities that are changing. So let me go back to this next one. So this is some of our future work that we're working on. We're developing tools inside of our system that will allow you to predict next steps, predict trends and flows of people. So this is our predictive real estate tool that we just kind of drafted together, and this is not final. This is something that I'm probably not supposed to be showing you, but it shows, so if market's moving upward in 12-month prediction, it's in the dark green. If it's downward, it's in the red. And this is based on Zillow data, which is also in the data observatory, and you can access. So you can basically see the patterns, and we've kind of laid it out pretty clearly, and you can look for places that will be going up or down. White means that it was either neutral or they didn't have enough information about it. Which Manhattan? I mean, I'm sure that's just neutral. So that's actually all I have. But if you want to try it on an account, this is a boosted account. Just fill out the form, and we'll give you a little bit extra space and an extra tool in there. And I guess I'll open it up to see if there are any questions.
The fear I'm getting is I don't know how to code.
Yeah,
and
that's a common.
There's a lot of that. So do you have a tutorial so you can use that? I don't know Python.
Yeah, we have a ton of tutorials.
Okay, so is it on the site or do you go to YouTube?
So academy.cartodb.com. Soon, I just want to preface this with soon, there won't be as much coding.
You were saying,
we're in development. I've seen it. It's beautiful. It's coming, so a lot of the stuff is drag and drop. A lot of the analysis tools specifically, we're making it so that we can just crank out analysis tools really fast, and they're just like point and click. But we also have the people that still want to code. So we're making it, everything in our interface is flippable. So you can do the automatic, the single button push, and then you can flip it over and customize it into whatever code you want. If you want to learn that coding, the Academy Lite's a great place to start. It's 5 minutes. The online mapping for beginners is an hour, but it's really wonderful. There's actually a data observatory piece in here. Data observatory doesn't come with the free accounts because we're still testing it. So give that some time. A session on map design if you want to start learn about design. And then SQL and Postgres is in this part. I actually recommend, there's a great app called Learn SQL. SQL is a really wonderful language to work in, and I really like using it every day. Learn SQL. It's an Android and iTunes app, and iPhone app. This is brilliant, and it taught me SQL so quickly. And I use it on the subway when I'm bored to refresh myself.
Yeah.
And then when I'm in the middle of something and I'm like, I can't remember how to do a stupid insert statement or why I'm supposed to do that. And I just open it up and I go back to the lesson that taught me that, and it's right there, and it's kind of fun. So I highly recommend this, and there's one for Python and JavaScript as well. So I know these things are hard to learn, and we don't want to make everybody have to learn them. So there's that, and then the Academy again
Where
is
was the Academy? Is it on your site or
like
Academy?
academy.cartodb.com is on our site.
Okay.
So and then there are new lessons coming out there all the time. There are actually some even further lessons. You can learn how to use our JavaScript libraries, and then you can do some more advanced mapping, and then how to pull from an external API, which is kind of great. So you can pull data in from places that offer data up or as a service. And then finally, there's some community content that's available too.
Cool.
It's a really great, big learning. We're always adding to it. Big learning site.
Can I speak to that last point? Because I teach programming for this.
Oh.
Most of what you were seeing was not coding. It was cutting and pasting
Yeah,
somebody
yeah, yeah.
else's code.
Yeah.
It was beautiful, and
Making slight
I didn't
edits to it.
understand it though, yeah. But, and that's the key, is what people say, to cut and paste it.
Yeah, it's kind of a great way to do it. I mean, it's kind of what everybody does. Someone actually said to Chris Wong, who used to work for us and now works for the Department of City Planning, said, "If you aren't coding, you're not Googling hard enough," which I thought was a little bit of a cheap shot, but it's kind of true, because you can find someone's struggled with what you're struggling with before. So don't be shy about Googling and trying to find somebody who's doing exactly what you're doing. Stack Exchange is your best friend. Yeah.
Rich countries tend to be data rich.
Yeah.
And, your amazing maps there for New York City, for the US, that's based on decades of boring, painstaking work and getting our data into spatial format.
Right.
So what does a tool like Carto offer a poor country that's also data poor?
Sure.
And that's trying to take the first steps in building the spatial
So I
format?
went and so Sarah Williams is a friend of mine, and I went and spoke to her class a little while back, and they were doing Kenya Transit Project. They were doing the Nairobi bus system is really distributed, and it's like a lot of different owners all doing their own thing. The bus lines change every day, and there's one application that was kind of harvesting the conversations that were happening about it, and she used CartoDB to take that application as a center point, look at the what was coming from that application, and then use CartoDB to map and also create advocacy projects from that. So a lot of times it takes starting up a data collection process, but if a country is, I don't have a solid answer for if there's nothing. I think that it's. I always want to start data collection projects myself. So it's once the data exists, we can help. And if it doesn't exist, we can help you figure out how to make it happen, like Sarah's doing in her class. But we offer our tools up for anybody who's doing stuff like that, so that we can help them understand how to do it a little bit better and a little faster, and we give support.
If I can follow up on that, even in a data-rich country like US, there's very little data, local data for poor people, which is the kind of research I do. And in our latest research project, actually we've used CartoDB very well so it's in inner city communities in Milwaukee. And we've looked at, this is a long and comprehensive project on urban gardening, community gardens and urban agriculture and green environment. It's environmental social justice focus, and also involves food equity issues and all of that. So for that, there's a lot of data collection we did, and working with community groups. But we used CartoDB and other products because we wanted to find alternate software that wouldn't cost these groups anything.
And the key to that is hardware, because the hardware to run some of the other programs that are very expensive on top of it is really hard to maintain for a lot of organizations. And you're exactly right. The U.S. is not necessarily a data-rich country in a lot of parts of it, because the data is not available for certain. There's definitely an inequality in data as well. So yeah, we always are willing to help, and we should probably talk afterwards.
We've
'Cause that's
actually
something.
had really good success with it, and the project is continuing, and it's being adopted by community organizations we're working with.
Great.
So it's a sustainable project in
We just
understanding.
gave a grant to GreenMap, which is a mapping platform that's been around for a very long time. Wendy Brower over there has been making environmental maps for cities for 20 years now, and we're getting them into CartoDB so that they can somebody can start up a green map in a city free. With all the icons that she has available, and take all of her work and apply it to whatever city that they're in very, very quickly. So we're putting a lot of money into grants to help projects without resources to make sure that they have them.
So I should talk to you.
You should definitely talk to me, yeah.
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 I'm curious. I think I may have missed it. But it seemed like all the examples you gave were vector data, and I was wondering if CartoDB also supports raster.
So we do raster through WMS, but we aren't really. We deal with a lot with storage, and raster is. We kind of haven't gotten there yet. So we do a lot with raster data. I'm sorry, with the vector data, and our relationship with raster is basically we are very good with base maps. Let me show you. So we can take raster data in WMS form. So we can import almost anything that is in WMS in any base map style. Getting the images in, you can. There are ways to do it with external development to bring raster in, but we don't have it inside of our platform. Okay, I think I'm over my time now.
Yeah. Yeah. Thanks a lot.
By the way, incorrectful is in the Merriam-Webster.
It is? Is it really? Okay, good. I'll stop saying that. I'll stop insulting Santiago. Is concerning?
Yeah, not so good.
Yeah. Go ahead.